Good morning, dear students, and welcome to Vista's e-learning and online educational platform. My name is Denzil, your physics tutor for class 11. So let's get started with today's session. In the last session, we discussed two different physical quantities, namely distance and displacement. So now we will classify those two physical quantities under what are called as scalars and vectors. This is a session 2 of the chapter motion. So in order to understand the concept of scalars and vectors, let us look at an example, which is this ball. Assume that this ball has a certain mass. Any object which occupies space has a mass. So let this ball have a mass which is m equals to 200 grams. Now, to specify a mass, do I have to point out what direction the mass is? Not necessary, right? So in this case, I have one such quantity which does not rely on a direction. And those quantity which does not require directions are called scalar quantities. And mass is one such example which is a scalar quantity. Now, on the other hand, to this ball, if I apply a force, now observe, I'm going to apply a force forward, and there I apply a force, and you notice the ball displaces. It's because that I applied the force in a forward direction, the ball displaced. So force is one such quantity which relies on the direction. You also define force by a push or a pull action. Push or pull specifies the direction. So force is what is called as a vector quantity. So let's make a quick note of these two quantities called the scalar and vector quantities. Now, scalar quantity are those which have magnitude. They have a certain value, but they do not have a direction. So when I use the word magnitude, it means a value to that physical quantity. So scalar quantity has a magnitude, but no direction specified. Okay, so these type of physical quantity which have magnitude but no direction. Example, one example I gave you, which is mass. Can you think of another example which has only a value but no direction? Think of another example which has only value but no direction. Did you guess? That's right. Time. Any other? Temperature. Any more? Yes, there are more. I want you to go ahead and explore what are those quantities which have only magnitude, a value, but no direction that is assigned to it. Now let us look at another quantity, which is a vector quantity. Vector quantity are those physical quantity which has a magnitude and a direction. So they have both. They have magnitude and a direction. So especially when you deal with vector quantities, example like force. The last class we discussed one other physical quantity, displacement. Soon you will see that there is also other physical quantity like velocity and acceleration. So here I'll put displacement, distance as a scalar quantity, because when it comes to calculating the distance, there is no use of finding the direction. But when it comes to finding for a displacement, you have to find the value plus in which direction it is moving. So these are the two different types. All the physical quantity that are around us, all the physical quantity can be classified under these two different types, which is a scalar quantity and a vector quantity. So go ahead and explore more of the scalar quantity and vector quantity. Now, first of all, let us discuss a little more about this vector quantity as to how to represent a given vector quantity. Now, one example I used, which is a force. So how do we denote a force as a vector? Now, force is usually represented by a capital letter F. How different is it from a scalar quantity? Now that it is different type of a quantity called a vector, you have to show the difference between a scalar and a vector. So for a vector quantity, we usually denote it with an arrow overhead. So you see, you first write the letter and then you denote it with an arrow overhead. This represents a vector quantity. So now this force is a complete representation of a vector quantity as F vector. So how do you read this? F vector. Okay, because you have an arrow overhead, it says F vector. All right. So now we need to discuss how to specify the direction. We know how to calculate the magnitude. There is no problem in calculating the magnitude. Magnitude meaning finding the value. How do you find the value for a force? You have learnt in lower classes, F is equals to ma. Or you could also read it as F vector equals to m times a vector. So I'll write that down, not to worry. F vector equals to m times a vector. You see, you have a force, which is a vector quantity, acceleration, which is also vector quantity, mass has no arrow overhead. So what type of a physical quantity is it? Option A, is it scalar quantity? Option B, is it a vector quantity? That's right, the answer is a scalar quantity. Okay, so mass here is a scalar quantity. So now that you know how to find the magnitude, that is not the problem. But how do we find the direction? That is where we discuss now how to represent a direction. So let us take this particular example where an object displaces along a number line. Okay. So I have a box which is located at 0. This box is moved forward 3 places forward. Okay, the box is moved 3 places forward and 4 places backwards. 2, 3, 4. Find the distance and the displacement of the box. Distance and displacement. First, what would be the distance? 3 places forward, so 3 units. 4 places backwards, 4 units. 3 plus 4, which is equals to 7 units. Pretty simple. Yes. Now what about displacement? Displacement, on the other hand, by definition, it says shortest distance between 2 points. Which are the 2 points? The initial point and the final point. Which is the initial point? 0. It is starting from 0. And which one is the final point? Have a look at it. The final point where it lands at is -1. Hurry. We're taking -1 in this case. How is that even possible? Now remember this, that when you walk forward, a sign, a mathematical sign that you can give is a positive. When you walk forward, you give it by a positive sign. And when you walk backward, what sign will you give? A negative. Similarly, going up is positive, going down is negative. So that is one way of representing a direction. A direction can be given in form of a sign, positive and a negative sign. Remember, positive forward, negative backward, positive upward, negative downward. Or the other way that you can also describe the direction is by compass. So in a compass, you have north, south, east, west. See, the two different ways how you can denote a direction. One is using a compass, two is using a sign plus or minus. But here we are not using a compass. Rather, we use the signs to represent a direction. So displacement, initial point 0, final point -1. The formula that you use here is final point, final minus the initial. Okay, final minus the initial. This is how you find the displacement. What is the final point? Final resting point is -1. Initial point, initial resting point is 0, minus of 0. -1 minus 0 is still -1 units. You observe there's a sign here. So what does it tell you about the direction? Is it forward or backward? Sign is negative. Will it be forward or backward? It will be backward. All right. So you take one step back, and that will be the displacement of a given box, which is moved 3 steps forward, 4 steps backward. So in your textbooks, the displacement are usually represented given as x2 minus x1. x2 being the final point minus x1 being the initial point. Or sometimes they may also write it as xf minus xi. x suffix f minus x suffix I. So this is also how it may be given in your textbook. But the difference between the two, the final minus the initial, the difference between the two is given by a short term, a short and sweet term, which is by using this symbol delta of x. Delta is a Greek letter. Delta is a Greek letter which represents the difference. Do you see there's a difference between the two? So this delta represents the difference. So easy way to find displacement. Okay, now let's have a look at an example and try to solve the following. So go ahead, read it with me. It says, an athlete runs around the circular track twice and returns to the same starting point. If the radius of the track is 22 meters, find the distance and the displacement of the athlete. So let's say an athlete who starts from this point, goes round this circular track how many times? Twice. Okay, he goes round the circular track twice and eventually ends at the same point, the starting. If the radius of this circular track hey, come on, I needed the dotted line. So guys, help me construct this dotted line. So give that, and I think should be it. Yeah, not bad. Now stop stealing it. Don't steal those dotted lines. So let it be there. Because if I try to construct another line, it vanishes. Look, someone stole the dotted line once again. Please don't do that. Return back. Right. So radius is about 20. Guys, come on. This is not funny anymore. Return the dotted line, or rather draw it by a straight line. 22 meters is the radius of the circular track. Now you need to find the displacement and the distance of this circular track. Distance first. Now since this person is going around the circular track twice, he's running only along the boundary of the circle. Even in a cricket stadium, you go around the boundary, which means you're covering the outer edge of that field. So here the same, in case of an athlete, he's only covering the boundary of this circle. How do we find the length of a boundary of a circle? This length of a boundary is what is called as a circumference of a circle. Now, how do we find the circumference of a circle? 2 pi r. Okay? 2 pi r. But since the person is going around the circumference how many times? 2 times. So 2 times 2 pi r. Do you know what is the radius r? Yes, you do. 22. So 22 times 2 times pi times 22. 2 times 2 is 4. 4 times 22 is 88. So total of 88 pi meters. I've not multiplied the pi. That's because pi is an irrational number, not unlike your apple pie or whatever pie that you're picturing, not that pi. Pi as an irrational number. But still what fascinates me is when it comes to learning about pi, why is pizza in a triangular box but circular in shape and cut into triangles? It's still a mystery. So I'll leave it up to you for you to understand why exactly that is. Now, calculating the displacement. What about the displacement? Since the starting point and the final point is the same, starting and the final point are the same, what happens to the displacement? So, let's think of it this way. Now, what I want you to do is look at this pen, okay? Now, close your eyes and now open your eyes. Now, did the pen displace? Did it move? Now, you may answer, no, it did not move. But actually, in fact, it did. You can go back like 5 seconds ago and then you see me moving the pen. So this is the same case what happens in case of a displacement. If the initial and the final point are the same, though the person has gone round the circular track twice, it still seems like he did not move from the position. So what happens to displacement is ultimately 0 units. All right, with a smile. So this is one more fascinating thing about a displacement. So let us look at the comparison between the distance and the displacement by this table shown here. Distance, displacement. Distance, we define it by total path length transverse. Displacement, we define it by shortest distance between the 2 points, the initial and the final. Distance is a scalar quantity which does not rely on direction. Displacement is a vector quantity which requires a direction as positive and negative, which we noticed earlier. Distance only has a positive value. It cannot be negative. If the object is moving, then it should have only positive value. But displacement, on the other hand, can be positive, negative, and zero. So we notice a couple of examples of positive. We notice one example where we have the answer as negative, and the other, the previous question where we notice the displacement being zero. All right. So I hope I made this easy for you, the comparison between distance and displacement under the two categories called scalars and vectors. And now moving to a choo-choo place where we have train. So what I want you to observe in this choo-choo train is that when it's moving from one destination to the other, there are break in between as to the distance between the two as 15 kilometer, 30 kilometer, and 45 kilometer. So as the train moves from one point to the other, you see that the clock is also ticking. I hope that clock is noticed. So let us have a look at this time. Let us keep a track of time as this train displaces from 0 to 15, 15 to 30, and 30 to 45. Okay, you ready? So I'll move out of the frame. Don't worry, I've not disappeared. Okay, I'm not Mr. India to disappear of a sudden. But have a look at it as when train passes from 0 to 15, what will be the time? 15 to 30, what will be the time? And 30 to 45, what will be the time? You ready? Okay. So go ahead, take a look at it. 0 to 15, 15 minutes pass by. 15 to 30, 15 minutes pass by. And 30 to 45, 15 minutes pass by. All right, so what you notice here is for every 15 kilometer, it takes 15 minutes. Okay, so first 15 kilometer, it takes 15 minutes. For the next 15 kilometers, it takes again 15 minutes. And for the next 15 kilometers, again, it takes 15 minutes. And that is why the total time taken, you will notice, will be 45 minutes. Starts from 12 and ends at 9. Okay, so total time taken will be 45 minutes. And once you split it into, which is 15, 15, 15 minutes. So what is that we need to make, what do we need to observe in this case is that there are, as the train moves equal distances, it takes equal intervals of time. First 15 kilometers, it takes 15 minutes. Next 15 kilometers, it takes 15 minutes. And next 15 kilometers, it takes 15 minutes. So this train travels equal distances in equal intervals of time. Such a motion is what is called as a uniform motion. So make a note of this.
Welcome back, dear students.
So we left off at this train which is executing a uniform motion. Now let us try to define what is uniform motion. So uniform motion is said to be executed if an object covers equal distances in equal intervals of time. Equal intervals of time. And so is the case in this example where a train covers equal distances in equal intervals of time. On the contrary, from a uniform motion, you also have which is non-uniform motion. And when is an object set to execute non-uniform motion? When it covers unequal distances in equal intervals of time. Unequal distance in equal intervals of time. So this is how you distinguish two different types of motion, which is uniform motion and a non-uniform motion. So if one single object is set to execute these two, what if you have two different objects? Now here let's have a look at an example where two different objects are executing a type of motion, but this time the two different objects are racing each other. The objects here are car, let's say car A, we'll choose an ink, yellow, car A, car B. So these two cars are going to race each other. Now let's have a look at it. Who wins the race? Is it car A or car B? 3, 2, 1, go. So you observe that car A wins the race and comes first, followed by car B. Now, why did the car A win? It's because it traveled faster. So this measure of quantity as to how fast an object moves, this measure of quantity of how fast an object moves can be discussed under two different categories called average speed and average velocity. Average speed and average velocity. So average speed meaning the average speed across the whole journey. In your lower classes, you might have discussed speed, just speed, but not as an average speed. So average speed is the speed throughout the journey. So average speed is defined as total distance divided by the total time taken. On the other hand, average velocity is defined as total displacement divided by total time. So you see there's a difference between a speed, average speed and an average velocity. An average speed relies on distance and average velocity relies on displacement. So among the two, which is the physical quantity, which one falls under a scalar quantity and which one falls under a vector quantity? Since average speed is defined as a distance by time, distance is a scalar quantity, therefore average speed should also be scalar quantity. So this is a scalar quantity whose SI unit is meter per second, also given as meter per second as an exponent form. On the other hand, average velocity is a vector quantity because displacement is a vector. So vector quantity whose SI unit is the same as average speed, which is meter per second, or given in exponent form, meter per second. So I hope I've made this easy for you. The two ways how you can identify how fast the object moves as an average speed, and also as an average velocity. Let's take a look at a problem based on this two physical quantity of average speed and average velocity. So go ahead, read it with me. It says a car is moving along a straight line, say OP in figure 3.1. This is a figure 3.1, which also happens to be in your NCERT textbook. You can follow your NCERT textbook, or you can take a look at here. It moves from O to P in 18 seconds and returns from P to Q in 6 seconds. What are the average speed and average velocity and average speed of the car in going from O to P? That's the first case. O to P as the object moves, or which is car in this case. What will be the average speed and average velocity from O to P and back to Q? So the car moves from O to P and then back to Q. So what will be average velocity and average speed? So let's find the first case, average speed and average velocity from O to P. Average speed, that is case 1. Case 1, or the first type, which is from A. We can also put it as A part. Average speed, total distance. What is the total distance from 0 to P? O to P? 360. And how long does it take to reach from O to P? 18 seconds. And once you cancel, you get 20. So therefore, 20 meter per second. Scalar quantity, I have not given any direction, which is by sign. Now let's find the average velocity again for case 1, which is A. Average velocity, which is equals to total displacement, final point 360, initial point 0. So 360 minus 0 divided by total time 18. 360 minus 0 is still 360, and then 360 by 18, you still get 20 meter per second. Where is the direction? It is a vector quantity, so you have to assign a direction. Positive. Why? Because it is moving towards the your right hand side. So right hand side are all positive, left hand side are all negative. So therefore positive 20 meter per second. Now try to find the answer for B. From O to P and back to Q. From O to P and then back to Q. Like that. And then back to Q. Total distance 0 to 360. And then back to from P to Q, the distance is 120. How is it 120? 360 minus 240, which is 120. Okay, so I'll make a note here. Average speed, which is equals to 360 plus 120. And how did that 120 come? 0 to P, 360 plus 120 from P to Q, divided by total time taken. O to P is 18 seconds. O to P 18. I'll make note of that. Plus P to Q in 6 seconds. P to Q in 6 seconds. So total will be 480 by 24. Yes. And 480 by 24 is 20 meter per second. Again, no signs given, positive, negative sign. I'm not going to give because it's a scalar quantity. Now we need to find the next part, which is average velocity, where average velocity from O to P and back to Q. Average velocity is total displacement. And what is a total displacement? Final point minus the initial point. That is 240 minus 0 divided by total time taken is still 18 plus 6. So 240 divided by 24, which is equals to 10 meter per second, but still in a positive direction. So this is how you identify the average velocity and the average speed for a given case. And that is all I have for today. Do visit us at www.we-learning to get more details about our classes. I shall see you in the next session. In the next session, we will discuss what the graphical representation of a velocity. So I will see you all. Take care and bye-bye.